So I think it's fair to say that when it comes to setting up angled parts, especially in the mill, it's an area that's a work in progress. I mean, I do have these angled blocks, but I made these, obviously, and I only have them in a few specific angles. Now, I really have been meaning to make, or at least buy, one of those sine bars, but I just don't have the angle blocks to go along with them. I mean, the closest that I have are these parallels, and they really don't count. And really good gauge blocks are pretty expensive. Although that's not really an excuse for not having picked up one of those angled parallel sets though, and that's something that I really do need to buy. Anyway, a few days back, a friend of mine sent me a photo of a really cool looking angle plate that he'd found on the internet. I suspect that it's more for general workshop setups because I'm not sure how accurate one of these is, but I took one look at it and I knew I want one of those. So step 1, I need a design. The original photo doesn't list or link to any, so we're gonna have to make our own. Now most people wouldn't want to do this by hand using a calculator, and I agree, and that's exactly what SolidWorks is for. Now the original posting says this is roughly 5 inches long, and I'm going to make mine roughly the same size. Although obviously I'm going to do this in metric. Obviously. Now I did do 1 or 2 designs to try and scale this down to maybe 3 or 4 inches. But it very quickly became obvious that trying to make that moving pin would be very difficult once we tried to scale it down. I'm more than certain that the original one was cut on some sort of CNC machine. And I don't have one of those, which means the design needs to be changed. And the design that I eventually chose limits how small the moving pin can actually be. And of course, as the design shrinks, the tighter the tolerances need to be. The tolerances here are still pretty tight, but as it shrinks, for every few microns it's off, the larger the error that we're going to see in the angle. Now in terms of actually drawing this up on the computer, the only part that's difficult is making that top section which swings. And really, once you figure it out, it becomes quite straightforward. Now in short, what we want is that along the length of it, we want 9 holes that are equally spaced, plus a bit of material at each end. Each hole will be an increment of 5 degrees, and we'll start at 5 and then end at 45. So let's just say, for example, we'll make the end hole 105mm away from the hole or the fulcrum, making sure to account for the extra height because that pin is raised above the plane that the pin carriage rides on. We can then add the height of the pin carriage that I've designed, and then we can angle it to 5 degrees. And just like that, that's the location of our 5-degree hole. We can now do that 8 more times, and now we have our 9 holes with our locations. And finally, we'll then cut away the bottom. We'll then chuck it in an assembly and then double check it all just to make sure all the angles are correct. Nothing left to do, but... Now before I left to come here, I did print out the parts as e-drawings, if you want to call them that. I mean, the first few ones aren't that bad, but the last ones are pretty messy and there is a lot of missing information. I mean, I've certainly made worse ones than these and they would not pass in a good machine shop, although they'll pass here because A, I have low standards, and B, I can read them, which is really all that matters. And because these holes, well, sort of everything really needs to be spot on, I've gone ahead and I picked up some reamers and some precision ground steel, just to try and keep everything as close to the CAD model as I can get. And we'll see later on just how close I get. You know, I'm not expecting sine bar level accuracy, but I think if I'm within or less than about half a degree of accuracy, I'll be pretty happy with it. Half a degree is quite a common tolerance that I've seen, so anything less than that and I'll be happy with it. Outside of that, I have some 1020 bar stock, which is sort of the right size, and also rather conveniently, it's the only size that I have. So I'll go ahead and get it cut down, and then we'll go from there. So what we now have are the two pieces now cut down and cleaned up. So the first thing that I'll tackle is the base. There's a fair amount of material to remove here, so to try and remove it as quickly as possible, I'll switch over to a carbide end mill. Also, if the mill sounds a bit poorly, the bearing on the spindle driver has given out, and that'll be replaced sometime during this video. You'll hear it when it happens. But for the moment, it's going to sound a little bit rough. Okay, so that end mill is absolutely shredding its way through metal. And even though it is carbide and it is getting a bit of coolant, it's still a little bit too much heat, even for my liking. So what I'll do is I'll switch over to the flood coolant. And just like that, I mean, it is night and day. It's just tearing its way through the steel and it's staying relatively cool. And most importantly, it's not throwing hot pieces of metal right at me. So with the step down now machined, I now need to cut a slot. Now before I go too much further, the coolant pressure does feel a little bit low. What I'm really looking for is for the coolant to sort of blast away the chips out of the channel, and I know the pump can do it, but I'm not really seeing that here. And yep, that'll explain it. Low coolant, and it could really do with a bit of maintenance. I mean, as far as it goes, it doesn't smell rancid or anything like that. It's just a little bit low, and some of it has come out of solution. What I'll do for the moment is just top it up, mix it up, and then see just sort of how it goes. This stuff's been working fine for the past 2 years, so we'll get a bit more use out of it, and then if it needs to be replaced, we'll get it replaced. And yeah, that is a lot better than it was before. With the slot now cut, I'll then drill a hole and then countersink it for a pin. And that is the bottom part now done for the moment. The next thing we need to do is the sliding pin assembly. Now what I'm looking to do is join a piece of silver steel, which has been surface ground to exactly 8mm, and then join it to a machined base. Now the stem of the base needs to be kept as thin as possible to allow the pin to have enough clearance on each side to allow it to locate at each angle. So to start off, let's work on the base. I have a piece of off-cutter steel which has probably been sitting around in a drawer for the past 4 years, and now finally I've found a use for it. So the first thing we'll do is get it cleaned up and squared. I'll then machine away a step down on each side so that it locks or locates into the channel on the bottom piece which we machined earlier. Now I'm not sure how well it translates to video, but that fit is pretty much perfect. All it needs now is for the inside edges to be relieved. As it is at the moment, it's not currently sitting flush, and that's because the edge of an end mill is not a perfectly sharp 90-degree corner. So going in with a hacksaw blade is good enough to relieve it. and that is a really good fit. Now unfortunately, when I was drawing this up in the computer, I didn't account for the radius of those two back corners. And as it is at the moment, the pin carriage can't move back far enough. So I'll go back to the mill and remove a bit more of that bottom material that I didn't machine last time. And now it moves far enough back to work. We can now flip it and then machine another step down in each side. This will be for mounting the pin. And once that's now done, I'll drill a hole all the way through it, and this will be for an M3 screw. And the screw is going to be used to hold that pin in place. Alright, I think that looks pretty good. What we need to do now is make the pin. Again, this stuff is precision ground high carbon steel, so probably similar to W1. So whilst it isn't hardened, and I'm not planning on hardening it, even in its soft state, it's still pretty tough and it should hold up. I now need to make a 4mm wide channel. And unfortunately, the only end mill that I have on hand that is small enough to do that is only 2mm wide. And I can tell you, I've broken a lot of these in the past in relatively soft steel. And unfortunately, this stuff here is way tougher. So what I'm going to do here is just take it easy and just, well, wish me luck. So I'm only going to be taking about 0.3mm per pass, because if I do snap it, and that is really easy to do, this is the only 2mm end mill that I have, and if I snap it, you could probably put the project on hold for a week. So I'll then get a hole drilled and then tap it for M3. And there it is, once it's all assembled. Now I've measured the height from the bottom edge to the top, and it's pretty much spot on dimension. So with that now done, let's get the swinging part now made. Now getting the holes exactly on spot and exactly on dimension is what's going to make or break this project. And I really only have one shot to get this done because I just don't have any spare metal if I muck this up. Thankfully, I have the DRO, and as long as I spot each hole, and I use a sharp drill bit, and then I ream it, it should be as close to being spot on as it can be. With that said though, being off by only a few microns will show up when we test it. So after doing the spotting, I'll then drill the holes using a 19/64 drill before reaming it to exactly 8mm. With all that said though, whoever did the shaft on that reamer, well, all I'll say is that is almost impressive in just how bad that is. Thankfully though, the bottom is concentric with the top, so we'll just see how it goes. And once the holes are now drilled and reamed, we now need to make a rather large step down on each side so that the centre fits into the slot. Now I could do it using an end mill, but it is a fair amount of material to remove, so instead I'll remove the bulk of it with the face mill. Now the original plan was to do it all using this one, but the finishing inserts are having a real tough time with the interrupted cuts on those holes. So instead I'll swap it over to the normal face mill, and because the sides are angled, I'll have to do the finishing pass with a regular end mill. Alright, I think that turned out looking pretty good. With the first side now done, we can then do the same thing to the other side. And the final thing left to do is remove all the material on that bottom side. Now I don't really have an elegant plan of removing all this material, so I'm just going to come in with an end mill and remove as much of it as I can. So I'll just take it as slow as I can and do the deepest cut that I can do with this end mill. And with that now done, we only have two small things left to do. The first thing that I need are some washers to go between the base and the swinging angled component. They're only 0.3mm wide, so they'll need to be made from some brass. I also need a pin for the swing arm to pivot on, and because I didn't ream these holes, I'll make the pin to be a nice snug fit. Alright, and there's the components now made. Nothing left to do, but... Alright, so between you and me, these punch markings did not come out as nice as I had imagined. So let me just... Yeah, that looks a lot better. You know, apart from the punch marks, I think it turned out looking pretty good actually. It moves nicely, it drops into place well enough, and I do quite like the look of it. Now initially there was quite a bit more wobble than I'd bargained for, especially at the far end, but with a bit more hammering on the pin, that fixed most of it up. The important question though is how accurate is it? And to test it, I've set up an indicator in the mill. We'll then set the angle, move the table a certain amount, and then see how far the indicator moves. Then using a bit of trig, we can then find out what the actual angle is. So for this example, we'll set the pin up to be a 20-degree angle. We'll then set the DRO and the indicator. For the purpose of this test, the 0 mark on the indicator is going to be at the 6 o'clock position. For the simplicity of this test, we'll move over 1mm, which is a little bit small. You'd want to move over a bit more, but for the simplicity of this test, we only moved over 1mm. And over that distance, our dial moved about 0.368mm. If we then take those figures and then plug it into a trig calculator, the measured angle that we get is 20.2 degrees. And you know, I don't think that's too bad for a rough angle setup block. That is well below the target of half a degree, and I think that is good enough for general purpose use in the workshop. And after testing each one, they all seem to fall between 0.1 and 0.3 degrees out, which is not too bad if you ask me. Now obviously the big caveat with a piece like this is that because of its size, it can't actually fit in the vise for holding parts. But it'll be a perfect match if I'm using an angle plate. Seems like a bit of a limitation, although if you are going to be using a true sine bar, they're usually going to be too big for a vise as well. And setting this up is a lot quicker, and more importantly for me, a lot cheaper as well. Honestly, I think this will work great on a drill press setup, and that is really what this is going to be used for. It's going home, it's going to be used for wood on my drill press. Which was really the plan from the beginning. And that's about it for now. I hope you enjoyed this video, thank you very much for watching, and I'll see you next time.